seconds to fill in here. All right. Good afternoon, everybody, and thank you for joining us today for the How to Understand ANSI Standards, Improving Hand Safety Using ANSI Hand Protection Standards, sponsored by Superior Glove. In today's 60-minute webinar, we're going to be joined by Shane Nider. Before I introduce our speaker this morning, I just want to take care of a few housekeeping items. As always, this webinar is being recorded, and a link to the recording will be sent to all registrants early next week. Questions for our speaker are welcome and can be submitted through the Q&A function at the bottom of your screen. Time has been reserved following the presentation to answer any questions that you may have. Also, there will be polls displayed throughout the presentation. Please watch out for this and participate. And with that, I'd like to welcome today's speaker, Shane Nider. Shane is a hand specialist for Superior Glove and has more than 17 years of experience working in the industrial safety market, with a focus on providing PPE solutions to the oil and gas and construction industry. Thank you, Shane, for being here. We really appreciate it. I'll now turn the floor over to you.
My pleasure, and thanks, Alex, and good day, everybody. Thanks for taking the time out of your day to join us for today's webinar. As Alex mentioned, my name is Shane Nider, Hand Safety Specialist with Superior Glove. We want to thank you for joining today. We're going to talk a little bit about hand protection and more specifically the ANSI standards and performance ratings for hand protection, and really try to simplify that for you and really give you as much information and in layman's terms that we can to help you sort of understand those performance guidelines as it pertains to hand protection. And as Alex mentioned, we love to hear from you, so we definitely encourage you to put those questions in the chat log. I'll try to save as much time towards the end of the presentation to answer those questions. We learned so much from your questions, so we definitely want to save a bit of time for that. If there's any questions that we don't have time to get to today, as Alex mentioned, following today's webinar, you will receive an email from myself, and that's going to have my contact information. I'll also get a copy of the questions, and I'll personally follow up on each and every one of those questions, and we can get into the weeds a little bit more as well. So I encourage you to get those questions ready, throw those in the chat, and we'll go through those. And again, as Alex mentioned, there'll be a couple poll questions that'll pop up just to kind of get us, the juices flowing, thinking about these performance levels, and we'll have a little fun with that. So just before we get into the main part of the presentation today, I just wanted to give you all a brief overview of Superior Glove and what we do, if you don't already know us, but I think you've probably guessed by our name that we make safety gloves, and we've been doing this for a long time, since 1910, so over 100 years. And so, innovation is in everything we do. We're obsessed with solving problems in the hand safety category, and it's really that innovation and that passion towards solving hand safety challenges and pain points that's led Superior Glove to have one of the broadest hand safety offerings and product offerings in North America. So we will be talking about the performance guidelines that surround hand protection today. We will be looking at some product features and benefits, but really, I think it's a good reminder to just talk about the hierarchy of controls. I think most safety managers are familiar with this approach, and we really want to keep this in mind when we're doing our hazard assessment and really when we're analyzing our work environment. It's a good best practice to really get into this flow rather than just jumping to PPE, what type of glove might be relevant for this application. It's really good to sort of start from the top down and really understand, can we eliminate the hazard? Is there a way we can physically remove the hazard or remove the employee exposure? Is there any engineering controls that we might be able to implement, additional safeguards? Any administrative controls, maybe it's training or application awareness training. We want to sort of get into the mindset of following the hierarchy of controls. And I'll, be the first to admit, in most industrial settings today, PPE is in use. It's definitely part of the full program and the approach, but we don't want to simply jump to PPE. We want to kind of follow this hierarchy of controls and see if there's other things that we can do in conjunction with the right PPE to really mitigate any injury or incident. So good reminder on the hierarchy of controls, and you can really implement this with any PPE category, including hand protection. So when we look at the common hazards and challenges within the industry, this is typically what we see, whether it's construction, oil and gas, mining, food processing, manufacturing. When we look at the common hand hazards, we're looking at things like impact. So forceful smacks onto the back of the hand, that could be from slipping a wrench, that could be from a hammer, that could be rolling pipe off a pipe rack. Common hand incident would be cuts and lacerations. And so common culprit there would be a utility knife or maybe sheet metal or ducting. So, lacerations and cuts, punctures. So that's going to be your stabbing motion from nails, screws, rebar tie wire is a common threat. So really, when we look at the common hand hazards within the common industrial setting, these are usually the things that we're going to come across when we're performing our hazard assessment. And not only with hazards, we also want to look at other challenges. Are drawings needed? Do we need to look at spec sheets and maybe hazard assessment forms? And so the ability to have some touchscreen capability, how is the PPE accessed, sizing, performance, comfort. So all of these things really need to be considered when doing a hazard assessment, when trying to identify what the right product is and what the right performance attributes are for that specific application. And so when we look at the common hand hazards that we face in the industry, the good news is there's aligning performance standards. And I think most people on the call are probably familiar with this. It's quite common for manufacturers of PPE to assign performance ratings to the level of performance they can expect from that given product. And so whether it's impact protection from hard hats, safety glasses, and protective footwear, maybe under ANSI or the CSA Canadian standard, it's no different with hand protection. We as a manufacturer assign these performance ratings, letting the user know what type of performance they could expect from that PPE. So when we're looking at our hazard assessment, when we're walking around our environment, we're looking at understanding what the right type of PPE is. There's a direct correlation between the common hand hazards and the performance hazards under the ANSI standard. And that's really what we're going to look closer at today, is those performance standards for the core 5: cut resistance, impact, heat, puncture, and abrasion. And there are some miscellaneous applications like anti-vibration, chemical, but today we're really going to focus in on the 5 ANSI performance hazards for hand protection and sort of how that relates to your approach with hazard assessment within your environment. And so you'll see those ANSI guidelines. You're not going to see CSA markings in Canada for hand protection. You will for other PPE categories. You will not see CSA markings for hand protection. It's under the ANSI standard, so the American National Standard Institute. And so really, as a manufacturer, if we want to make any claim, if we want to publish any performance standard on our product, and we do, we need to send that product out for third-party testing. So we do have a state-of-the-art lab in our facilities, and we align with the ANSI performance and the ASTM performance guidelines. But if, as a manufacturer, if you want to have that label, if you want to have that performance marking on the product for the customer, the end user, you have to have the results verified by an independent third-party testing. So yes, it's great we can test our own products in-house, make sure that they're manufactured to the highest standard above and beyond, but then again, sending it out for that validation. So when you're looking at products, when you're looking at your own products, we always want to make sure that those performance markings are there. If they're not, it's a good indication that that product hasn't been tested to the ANSI and ASTM guidelines. And so just a quick note there on the in-house testing. And so I'm going to throw up a quick poll question here on the screen, just again to get our thoughts around, get us thinking around these performance levels for hand protection. So question, true or false, the higher the ANSI product performance ratings are, the thicker and less dexterous the product is. So just a quick poll up on the screen for you there. So the higher the ANSI performance rating, the thicker and less dexterous, the less sense of touch you would have in that product. So just give a few seconds to answer that. Alex will go ahead and throw those results on the screen in a short moment here. False. So the overarching answer here is false with 80%. And yeah, I just wanted to throw that up there to sort of get us thinking about that. There is a common misconception in the industry, and for valid reasons. Maybe 5 years ago, there was a correlation between higher performance equals thicker, less dexterous products. There's been a lot of innovation in materials, a lot of innovation in yarns, and so manufacturers like Superior Glove are actually able to make higher performance products and not compromising on comfort and dexterity. So workers really shouldn't have to compromise safety versus comfort. So you'll find that products are getting more comfortable, more breathable, more dexterous, and offering higher levels of protection. So I just wanted to kind of dispel that misconception that, to get a high performance, the product needs to be thicker and not offer any level of dexterity. So sometimes that is the case, but more often than not, products are offering higher performance and still giving that great performance. And so just wanted to throw that out to the group. So good job there. And so the first category, and again, we're going to look at cut, abrasion, puncture, heat, and impact under the ANSI ASTM guidelines. And so the first one we have here up on the screen is cut resistance. Cut and lacerations are at the top of the list in terms of hand injuries and incidents. And for most safety managers, it's top of mind. And so when we look at the cut resistant testing, really the cut test uses a TDM 100 machine, and not to get too technical there, but at the end of the day, we're testing the materials using a blade, so a straight edge blade, similar to the blade you would find in a utility knife, an Olfa knife, that really sharp razor blade edge, and we're dragging that across the palm of the glove. And as we go up in scale or higher performance levels, we're adding more and more weight to the blade. And so that blade is dragged across the palm of the glove, and based on the force required to cut through that palm material, that's where we get the rating. And I think it's really important to note that standard is testing across the palm. However, manufacturers like Superior Glove go above and beyond. So although the test only requires us to test the material across the palm, we realize and understand that from a practical standpoint, you could get a laceration, you could get a cut across any point of your hand. So our gloves are designed, manufactured, and tested to have cut resistance 360, the entirety of the glove. The yarn itself is inherently cut resistant. So the standard requires testing across the palm. Manufacturers go above and beyond and make sure that that cut performance is 360. The entirety of your hand is protected. And so when we look at some of the cut resistant materials, and again, when you're working in your environment, doing your hazard assessments, materials are important. There's many ways to achieve cut resistance. And commonly now with your general purpose string knit palm coated gloves, we're using high performance polyethylene, so an HPPE yarn or a para-aramid. Probably one of the most common para-aramids trade name would be Kevlar. And so within any material, there's usually features and benefits, or usually a trade-off. So HPPE, very light, very cool, soft touch to the skin, very breathable, very soft and malleable. Whereas para-aramids like Kevlar, not as flexible, not as cool breathing, not as soft, but it's going to give you those higher thermal properties. So better for spark, better for thermal heat. And so it really just depends on the environment, what the application is, and then choosing those right materials. And so, if it's something extreme and you're getting into a metal chainmail glove, perhaps for food processing, well, that's a metal mesh. So you can imagine how good the cut resistance would be there. And then really in today's innovation and advancement, we're using composite or engineered yarn So that's a bunch of different yarns coming together, 2, 3, 4 yarns coming together and giving you the best of both worlds from comfort perspective, performance, dexterity, breathability, abrasion resistance, longevity. And so really when you're looking at cut resistant materials, just remember there's usually a trade-off. And so it really just depends on the application, which is why hazard assessments of the environment are so key. What are we doing? What are some of the characteristics? And then matching it up with those attributes for the specific product. And again, using those performance levels to indicate what some of those attributes are. And so there's going to be a common theme today, and it's that graduating scale. And so when we look more technically at cut resistance, we have a scale from A1 to A9. So there's 9 levels of cut when we're looking at cut ratings. And so when we look at the performance, we have the A in front. That's just the ANSI designation. And so really in layman's terms, if you want to group this in your mind, it's really what are those nuisance level applications, those low risk applications, paper cuts, material handling, small parts assembly. What's that low risk hazard for cut? And then you'll be in that A1 to A3. As you get into some more medium level or moderate risk, you know, you're going to be sitting in that sort of that A4, A5 range, middle of the road. That can be things like glass handling, HVAC, automotive, you know, some meat processing applications. And then on the other end of it, on the spectrum, you have extreme. So we're talking about glazers, we're talking about stamping facilities, we're talking about, you know, using those really sharp knives. And so really trying to, you know, from a general perspective, is this a low risk application? Is this moderate, or are we on the extreme? And I think most people, you know, when you're walking around your environment, when you're looking at your different applications and you sort of picture yourself doing that application, you can kind of ask yourself, you know, is this low risk? Is this moderate? Or no, this is extreme, like this is some really sharp stuff. And so now that you kind of have an understanding of the graduating scale, the higher the number, the more performance you can expect from that product. And so when you're analyzing your application, try to understand, is this a nuisance level application? Is it moderate risk? Or no, this is extreme. And then you can make the correlation with the correct product. We offer products and quite deep in all of these categories, whether it's an A1, an A3, an A6, or an A9. And then of course, different combinations from a material perspective and product design. And so the main thing to take away here is it's a graduating scale. And so you can sort of align that with your application. You know, as you're graduating up in severity, probability, intensity of the application, you can align these standards with the performance. When it comes to heat, so when we talk about heat resistant gloves, and we're talking in general thermal heat, so handling something hot, taking something out of an oven, a machined part, maybe some scrap cut off after using a tiger torch or a cutting torch. So really thermal heat. What am I handling, and how long can I hold that hot piece of material before saying ouch or dropping it? So really we use a hot plate and we have a sensor to measure that conductive heat, and the rating's really determined by the highest contact temperature, where the time to second degree burn is over 15 seconds and time to pain is over 4 seconds. So again, how long does it take for me to handle that hot part before I start to feel that thermal breakthrough, before I say, okay, this is getting hot, I'm going to have to put this down? And so when we look at some of the heat resistant materials, again, it's solely based on what the application is. Different materials will give you different attributes and different performance properties. And so when we look at, again, those general purpose palm coated gloves using a para aramid, something like a Kevlar, great dexterity, great grip, great mechanical strength, maybe some touchscreen compatibility there. But again, you may not be able to handle objects quite as hot on that extreme side of the spectrum. Terry loop, so sort of like a cotton feeling glove, but a terry loop, that's going to trap heat. So if you've ever seen sort of something like the UGG glove on TV or something like that, where it's the glove, the barbecue glove of all time, sort of a similar thing there. being able to handle extreme temperatures up to 608 degrees Fahrenheit or 350 degrees Celsius. Again, using different types of materials to achieve that. And then leather in general, great inherent heat, thermal property, great abrasion, generally a reason why most welding gloves on the market are made from leather. It's just got that inherent great heat resistance, great mechanical properties. So you'll see a lot of leather being used in heat. But again, it's solely based on what the application is and really choosing the best material for that application. And so again, as I mentioned, there's going to be a common theme here, which is good. Consistency is good. And so when we're looking at our environment, when we're looking at our heat applications, if we have them, again, just remember it's that graduating scale. And so level 1, again, 176 degrees Fahrenheit, middle of the road, level 3, 392 degrees Fahrenheit. And then at the extreme level of the spectrum, 608 degrees Fahrenheit plus. There's a plus there for level 5. Similar to cut resistance, having a specific standard, same with heat. The standard only goes up to level 5, but as a manufacturer, we certainly appreciate that some of our end user partners do have applications that go above and beyond 608 degrees Fahrenheit. We have the ability to test in our lab above and beyond that level 5 rating. However, we're doing that as a manufacturer. Again, the standard caps out at level 5. As a manufacturer, we can go above and beyond that. We can provide the test reports. So again, if that's a pain point for you, that you're looking for higher heat ratings over and above 608 degrees Fahrenheit, it just may be working directly with a manufacturer to find the right solution. But again, we use these graduating scales to say, okay, what is our heat temperature we're looking to protect against, and where do we fit in this spectrum? Is it low? Is it moderate? Or is it extreme heat where only a few seconds of handling this material, we're going to get a pretty severe burn if we're not protected? And so really understanding your environment, what heat you're faced with, and making those decisions based on the graduating scale. And we have so many options when it comes to heat. Again, just really what attributes are important to you based on your application. So impact resistant testing. Impact is the newest impact designation under the ANSI ISCA testing. There wasn't, 4 years ago, there wasn't an impact standard. There was, but it was for motorcycles. And so the industry recognized that as these impact gloves became more popular, the industry needed a standard. And so they adopted the motorcycle standard. They made a few tweaks to make it relevant for industrial settings. And now we have the ISCA impact standard. And really it's that testing on the back of the hand. Again, forceful smacks from a mallet, pipe rolling off a pipe rack, getting your hand stuck between two pipes coming together, slipping a torque wrench or a crescent wrench, anything that's going to offer a forceful smack onto the back of the hand. And so really when we do the impact testing, it's basically a weighted anvil that drops onto the back of the hand, on the back of the glove, and we're looking for those force breakthroughs. The higher the force, the lower the rating, the less protection. And so similar to cut, similar to heat, the standard calls for manufacturers to test up to the fingertips, the knuckles, and then really all points of the knuckles, but really not the full back of the hand. And you might think that that's odd or interesting, and we would agree. When you're working in the industrial setting, you could have a forceful smack on any part of the back of your hand. And so although the standard only calls for manufacturers to test the fingers and the knuckles, again, we go above and beyond. We make sure that those impact materials, whether it's a silicone, whether it's a thermoplastic rubber or other composition, we make sure that the coverage is there and that we're orientating those materials in such a way that you're getting that practical coverage. And so again, not uncommon for manufacturers to go above and beyond the standard, but that's really what we're looking at here, is protecting the back of the hand from crushes, pinch points, and other severe impact. So again, there's lots of different impact resistant materials. These are getting better and better, not just the material itself, but how we're orientating the material. By changing some of the characteristics of how we design that, how we shape that, you can get higher performance levels, but less material, which means more comfort, more dexterity, more flexibility, less fatigue. And so a couple different options on the screen in terms of material. And now even popular in welding is using a silicone material. Has a lot better thermal protection. You're not going to be breathing in that burning rubber like you would with a thermoplastic rubber. So we can use other materials for different applications if there's other scenarios like high heat or chemical or things of that nature. And so lots of different options, but the overarching theme here is to, and from a technical perspective, is really to understand those impact ratings. And so again, no surprise, it's a graduating scale. Level 1, low risk. Level 2, that moderate or medium impact force. And then level 3, sort of at that extreme. So drilling, rigging, moving pipe around, pipe work, things where there's a high severity of and high risk of injury. And so again, as you're walking around your environment, as you're overviewing and assessing your applications, ask yourself, is this sort of low risk? They might slip a crescent wrench, might get a little bruised knuckle, or no, they're on the end of a torque wrench. They could actually get a pretty forceful smack. Maybe it's a level 2 and then graduating up. So again, where do we fit in this graduating scale? And as I mentioned, the more force that's transmitted through the back of the hand on impact, the lower the rating. So when you look at level 3, less impact, less force getting through that glove, higher performance product, higher rating in a level 3. Most products we see on the market today are level 1, level 2, but again, for some of those extreme applications, you can get into level 3. And so just a little on impact there. Puncture resistant testing. So puncture, really think of that stabbing motion, taking screws or nails out of a pouch, sharp splinters from wood and other lumber, tie wire around rebar is a common culprit, very narrow, very thin, very fine. So really thinking about that stabbing motion onto the hand, a puncture threat. And so as the same with cut, it's really looking at the palm. That's where the protection is. And so when we're looking at that stabbing motion, it's all in the palm. If you're looking at a knitted product, you're going to have that palm coating. The puncture protection is in its entirety in the palm. So unlike cut being 360 in the entirety of the glove, it's not the same for puncture. The protection is in the palm, and the palm coating, whether it's a PU, a nitrile, latex, the puncture resistance is in the palm. And so just got to be careful there that if you do have puncture threats or applications on the back side of the palm, requires a very specific product. And so just want to reiterate that the performance testing is on the palm side of the glove, not 360. And the other thing to clarify here, the big takeaway for puncture is there's 2 puncture categories under the standard. There's large object puncture threat, and there's fine object puncture threat. So just for reference on the screen, large object puncture, there's the probe we use when we stab the gloves to test them and get that rating. And so again, that's things like rebar, that's things like nails and screws and splinters from wood. When you get into the hypodermic needle threat or the fine object threat, that's when we're talking about that really fine object. So if there's a reference here of the hypodermic needle, that's the test probe we use. That's how fine it is. And so that's why you want to make that clarification. Do we have puncture hazards in our environment? And if so, is it on the large object puncture or is it on the fine object puncture? Because if you were looking at the scale and you had a fine object puncture, like a needle, like tie wire, like MIG wire, and you were using a large object puncture rated glove, there's a probability that it would go right through that glove and you get a puncture, and you might be wondering why that is. And so just really want to make the clarification. Same graduating scale, 1 to 5, but you'll notice the newtons of puncture pressure force is in a direct correlation using a different probe. One is a large object, one is a fine object. So just to make it as simple as possible, Are we dealing with fine objects, or are we dealing with large objects? And then do we need to, what level of the spectrum do we fit in? Is it low risk, or is it high risk, or are we somewhere in the middle? And so the big takeaway for puncture is just making that clarification on where you sit. Are you dealing with hypodermic needles? Are you dealing with very fine materials that can come through the glove? Or are you dealing with larger objects? And so the last sort of thing I wanted to actually mention here is there's very specific gloves for hypodermic needle protection. There are gloves that are going to give you 360 degrees protection, but they're far and few between. Most puncture resistant gloves, including hypodermic needle puncture threat, are on the palm and the fingers. And so if you do need that 360 puncture for fine objects, there's a couple of options available on the market, but most needle stick or needle resistant gloves on the market are palm only. And so look for those markings, look for those indications on the spec, the features and benefits in the product specs, because you definitely want to make that differentiation and not get those two confused. And so again, graduating scale, just understanding what the puncture threat is. Abrasion. So when we look at abrasion, it's not necessarily from a true hazard. I mean, it could, scrapes, scratches, abrasion, but really when we look at abrasion, it's a good indication of longevity. How long is this glove going to last? What kind of usage are we looking at here? And can I get my usage down? Are we going through too many gloves versus our application? So abrasion is a good guideline to understand, okay, how aggressive are our applications, and do we have the right product that's giving us enough abrasion resistance so we're not burning through gloves 3-4 times a shift. The higher the abrasion rating, the stronger the glove, the more longevity you're going to get out of it. So in more robust environments, more extreme applications, you may want something that's a bit higher abrasion to give you that service life. And so we use a Tabor machine to test the gloves. Layman's terms, it's a spinning wheel with a piece of sandpaper on it, and it's revolutions. So that sandpaper spins on the palm of the glove, and we wait to see how many revolutions did it take before we got breakthrough of the glove. And so obviously the more revolutions before you break through, the stronger the material is, the higher the rating is going to be. But again, product may not be as breathable. Again, different types of products. So again, we look at different abrasion resistant materials. Coated gloves, the coating on the glove is really what gives you the grip, but it also speaks to abrasion. So some different palm coatings will give you better abrasion resistance than others. And so you may look at a nitrile palm coating or a micropore nitrile versus a PU if you're looking for different abrasion attributes. Leather by nature, inherent, leather is strong, leather is tough. If you look at animal hide, if you look at our skin, animal hide is tough. And so when we're looking at tensile strength, leather in general is high abrasion by default. And so that's why a lot of general purpose gloves, your driver gloves, your roper gloves, your welding gloves are made from leather, because it's just that high abrasion, high tensile strength. It's a workhorse. It's going to give you that longevity. And then there's hybrid gloves. You may be looking for the best of both worlds. You may want a bit of breathability, a bit of flex, a bit of dexterity, but you may need that abrasion resistant palm if you're handling lumber, if you're handling scrap materials, something more aggressive. And so, in a hybrid glove, you'll have the backside fabric and you'll have the palm side leather. And so we use these different materials in conjunction, trying to find, the best of both worlds for that application. And so that's why hazard assessment is so important, because we really need to understand as much about the application as we can, so that we can navigate into the right solution and not overprotect. We get a lot of questions about, well, if you have, to the top end of the scale in every category, why not just go to the top end? And that's really a good question, but we don't want to overprotect. If we overprotect, again, there may be some other challenges that you're introducing there. And so it's about finding the right glove that's going to offer the dexterity, the comfort, and really, what is the right glove? The ones that the employees will actually wear. And so that's the big focus there. So no surprise, abrasion, graduating scale. So on a level 1, you might ask yourself, why are we going through so many palm coated gloves? Might be abrasion. The product might be very thin. It might be made of a specific material. Again, as you graduate up the abrasion scale, so level 2, 500 revolutions of that sandpaper spinning before it broke through the glove. Mid-range for level 4 abrasion, 3,000 revolutions of that sandpaper before it broke through the glove. And then on the top end of the scale, a level 6, 20,000 revolutions of that sandpaper before it broke through the glove. And so you could see for really extreme environments where abrasion is really a hazard or a pain point, look at maybe graduating up in the abrasion rating. And again, it doesn't mean the product is necessarily going to be thicker, less comfortable, less dexterous. We have a lot of great abrasion 6 gloves that are very light, very breathable, very dexterous, but again, offering that really long service life. You're reducing your usage. And so yeah, that's what abrasion really speaks to, is how long is that glove going to last? What kind of performance can I get from longevity perspective? And so really just to kind of wrap up on the performance guidelines, again, a couple takeaways. It's a graduating scale, and it's usually, if you want to look at it in layman's terms, low risk, moderate risk, or moderate hazard, that middle of the road, and then on the other end of the spectrum, extreme. So as we graduate up, again, the number is going to get higher, offering more performance, different attributes. And so really asking yourself, as you're doing your hazard assessment within your environment, where do you fit in that? And then protection combinations, in the 400 of different styles of gloves that Superior Glove offers, you'll see different protection combinations. So you might have a puncture and impact threat. So you may need a product that offers good level impact, maybe a level 2, but also offering high level of puncture, and in this case with the brown glove, level 5. And so again, it's really about matching up your environment, your hazards, with the attributes that these gloves they're offering. And so there's all different types of palm coatings, different types of ways to manufacture gloves based on what your applications and pain points are. So we've got chemical gloves with impact, we've got leather gloves with impact, we've got dexterity gloves with impact, we've got high heat, and the list goes on and on. And so really trying to find the best solution for the application. And so I'm just going to throw up a quick poll question here. Alex is going to throw that on the screen. So true or false, the higher the ANSI product performance ratings are, the more protection the product offers. So in general, the higher the ANSI performance rating, the higher performance you could expect from that product. And so we'll just give a few moments there. Just a couple seconds here. All right, so again, true. So the overarching answer here, 92% is true. So again, we really want to associate that graduating scale, whether it's cut in grams of cut force, whether it's puncture in force of newtons, really assigning our applications and aligning our applications with these performance guidelines. And it's a great resource. Ideally, best state is within your hand safety program. If you're developing or refining your in-house hand safety program, really using these performance guidelines is a minimum level of protection for your applications, and then sort of working from there. And so, yeah, that's a true statement. And just so as we sort of wrap up the conversation and discuss presentation today, on the resources, as a manufacturer, we have a lot of great resources for you, superiorglove.com. And specific to today's webinar, the ANSI ASTM performance poster or summary sheet is a great resource. So it's that one pager, very easy to understand, it's laid out very well. So that's going to cover the scale. So whether it's cut A1 to A9, puncture 1 to 5, that ANSI performance guide is a one-pager, great for tool cribs, great as a training resource, great to incorporate into any hand safety program, and it goes through the 5 core performance hazards: cut, abrasion, puncture, heat, and impact. And it's just a reiteration of what we covered today. And so it can kind of be used as a roadmap for hazard assessment. And then one of the things that you'll find under the catalog section of our website is hazard specific product catalogs. So yes, we have our full line catalog, but our individual hazard specific catalogs are great. So if you're only interested in cut resistance, you can go and find the cut resistance product guide. It's a graduating catalog, so it starts at A9, the highest level of protection, and it kind of graduates down to A1. And so if you already know what level you're sitting in through your hazard assessment, you can go straight to the resource. If it's an impact, puncture, abrasion, those product specific, hazard specific catalogs are there for you. So very handy. And then one-on-one with your hand safety specialists. We've got folks like myself, hand safety specialists across Canada, across North America, and really across the globe. And so one of the things we love to do is work with our end user partners to understand what your pain points are in the hand safety category, and work with you on one to either further develop, refine, or even maybe implement a hand safety program within your organization. Maybe your resources are limited. You don't have to do all the heavy lifting yourself. That's what we're here for. So if that's you, if you're interested in having a further discussion around hand safety, we're here as your partner. And so don't be shy to reach out to us. You'll have my contact information following today's webinar, and certainly encourage you to reach out at any time. So those resources are available there for you. And with that, Alex, just want to save a bit of time here for questions. So I'm going to turn it back over to you.
Thanks, Shane. That was awesome. Thanks for that informative, engaging presentation. And I'm just going to pick through a few of the questions here. First one I'm seeing is, what is your opinion on half-fingered gloves for mechanics?
We do have some options that have the fingerless gloves if it's a sense of dexterity, if it's a sense of touch, if it's a touchscreen compatibility challenge they're looking for. I would recommend that through hazard assessment that we confirm that, by having those exposed fingers, it's not going to create a challenge. What we would want to do is try to facilitate fingerless gloves if it was a true desire and if it was practical, because sometimes if we don't facilitate those products, it leads the employee to cut the fingers off themselves. And we certainly don't want any modification of the PPE. We would rather have a glove where they could close those fingers back up after the application was done. And even more commonly now, we have a 21 gauge glove that's touchscreen compatible. 21 gauge is the thinnest glove you can achieve. It's bare hand feeling. And so with some of the technology nowadays, you should be able to get a fully covered 5-finger glove with touchscreen, breathability, dexterity, without having to take the gloves off. But if workers are cutting the fingers off or asking for fingerless gloves, I would entertain it. I would talk to the employee. I would entertain that and work with them to find the best solution, because if we don't consider that feedback, it might cause them to go rogue and start modifying the PPE. So yeah, just through conversation, you might find there's a better option, or it might be practical to have fingerless gloves. We do have them, so there is a need for them in some situations.
Awesome, absolutely, thank you. Alexander asks, a lot of lab tests have variation in the results between labs and samples. How does Superior ensure accuracy and which result to move forward with marketing?
So we always take, so 2 points there. If I think I understand the question correctly, is really not a lot of manufacturers do independent testing in a lab. So really the benefit of having our independent testing is we can work at a product until we're satisfied with the performance rating, or sometimes we'll engineer a glove based on an attribute and then test it and go, oh, wow, that's a pretty high level of cut resistance. We didn't necessarily set out to achieve a specific level of performance, but once we tested it, and then having that quality control by third-party testing just validates those performance ratings. And just one last note, we default to the lowest level of protection. So if we're looking at an impact glove, if we get high protection levels in certain parts of the fingers and lower levels in certain parts of the back of the hand, we'll default to the lower level of protection and mark it and publish the rating that way. So we default lower, not higher. And so that's just erring on the side of safety, put a safety factor.
That just seems like a good practice. And I'm getting a lot of questions here about the resources within the presentation today. Just to confirm with everybody, you will be sending those out sometime early next week.
Absolutely. I think just with the long weekend, that'll probably come through Monday. And again, superiorglove.com under the catalog section, and not just catalogs with nice products, but really good technical information. The performance guidelines will be there. And so, yeah, and then of course you'll have my contact information. I love to engage with our end user customers. So you can email me questions, comments, concerns anytime, and I'll definitely get back to you.
Awesome. Thank you. Tom says, you mentioned that the cut test for Superior is 360-degree protection. Does that mean that the cut rating on the glove is representative of the whole glove or just the palm as per the ASTM test?
That's correct. So we test to the ASTM guideline, which is across the palm. However, it's inherent, like 99% of the gloves we manufacture, if not 100%, are 360. The yarn itself is inherently cut resistant. The palm coating is going to give more cut resistance. If we're using a leather glove, we're lining the leather glove with a para-aramid or an HPP cut resistant liner, and we're not just lining the palm, we're lining that glove 360. So the other thing I want to mention is when you look at our products on our website, there's a picture of a hand with an arrow going around it. That's indicating the product is 360 cut. And so that's not the same for all manufacturers. So really good to know what the markings are and what performance ratings are and to what standard, because the glove requirement is across the palm, some manufacturers might only choose to put that cut resistant liner across the palm, save on thickness, cost. So, but we realize that it just makes more sense to have that 360. And so it's about knowing the product, but just to answer the question, yeah, it's the materials themselves are that inherent. And so just by default, we get that 360 protection.
Perfect. I see one here for para-aramid. What kind of 360 protection do para-aramid gloves provide against hot liquids at 400 degrees Fahrenheit?
It's a good question. I don't know the answer off the top of my head in terms of like any sort of melting points or anything, because a lot of our para-aramid gloves are paired up with a nitrile palm coating, PU. And so if it's a straight para-aramid, like a Kevlar, for example, yeah, if you look at our heat resistant offering in some of those hazard specific catalogs I was telling you about, you'll see that graduating scale. And when you get to heat 5, that 608 degrees Fahrenheit, you'll see a big Kevlar para-aramid mitt that looks like an oven mitt. And so yeah, para-aramids are great for heat resistance. And the way we orientate the material, the way we add different materials really speaks to the heat level. But para-aramid by nature is really great for heat properties. Not sure on the liquid side, please feel free to send me that question directly and I will definitely get you the official answer, the right answer.
Right on. Do the ANSI ratings address electrical arc flash ratings?
No, they don't. We do have, that's a great question. We do have some ARC rated gloves. So again, back to those hazard specific catalogs I was telling you about on superiorglove.com. Find the ARC rated catalog and you'll start to see some of our gloves that are FR or ARC rated. So and that would be usually under you know, the NFPA 70E and 2112 standard when we're talking about ARC and flash fire. So yeah, look more towards NFPA. There's a new NFPA standard for hand protection. If you reach out to me, I'd be happy to provide that information for you, but no, under ARC and flash fire, you're looking more at NFPA ratings, not ANSI.
Okay, perfect. What glove would you say provides the most protection when dispersing LPG?
Good question. I'm going to be honest. I'm not familiar with LPG. If there's
Okay.
a further explanation, if that's like a liquid process or an application or some type of material, but I would be happy to look into that and get those answers back to you.
And okay, Chelsea asks, are your gloves designed to fit men's hands, or do you make a line for women as well?
Great question. I appreciate that question. So really two answers to that. Our gloves today are mostly universal. A lot of gloves on the market are universal. And so the benefit of Superior Glove is we do very extended sizes on the spectrum. So we go down to a size 5, which is a double extra small, and we go up to a size 13 in many cases, which is a size 3 extra large. And so we do have a broader range to fit those smaller hands. With that said, there's been a lot of industry research feedback that, you know, there is a gap in the industry for ladies PPE. So a lot of manufacturers, including Superior Glove, are now innovating products that are specifically designed for the female hand, and not just females, but people with smaller profiles. And so making a glove smaller doesn't translate into fitting a lady's hand better. We have different contours, different thicknesses on the width of the palm, the finger shape. And so the gloves we're manufacturing now, we're just launching a new women's welder specific glove. And it's not just going down smaller sizes, it's actually mapping the contour of an average lady's hand. And so, not to get off too much on a tangent, but I just wanted to reassure the ladies on the call that manufacturers, including Superior Glove, are now focusing in on broadening out from just universal and making ladies specific PPE. And it's not just going down smaller in sizes, it's actually taking a look at the actual contour and designing the glove in that way. So good news coming for that, and it'll take a couple of years for there to be a broad offering, but we're definitely heading in that direction. So great question, and yeah, definitely practical and necessary. So
That's awesome. Thank you, Shane. Just a comment here from Kim. I had really good experience in the past with one-on-one review of needs with Superior Glove. So thank you for that, Kim. What are your recommendations for gloves used for hazardous chemical handling, and can you speak to the standards of those at all?
sure. We didn't cover chemical today, but one thing that I will tell you is all chemical compounds need to be tested, as all the other, you know, as per usual on the testing side. And so the best answer I can give you today, without knowing any of the chemical and attributes and stuff in application, you always want to first understand what the chemical is, and then obtain the SBS safety data sheet. And then in the safety data sheet, you will find a spot, I think it's usually section 8 for personal protective equipment. There's usually guidelines for hand protection and respiratory and goggles and protective clothing, but back to hand protection, it'll give you recommendations on the compounds. It sometimes can be very vague in general. Sometimes it could be as simple as follow the manufacturer's recommendations, and so not overly helpful, but a lot of times it'll tell you the type of material to use. And then going back to material, that's what it's about with chemical. Understanding what material is best for that chemical. Where you're going to find that is on a chemical resistant chart. I can provide that to you. There's different variations out there, but it's basically a scale of excellent, fair, and poor. And so again, when you're looking at, let's say it's toluene or benzene, you would pull up the SDS, you would identify the recommendation. Okay, are we looking at a PDA, a PDC, neoprene, nitrile, natural rubber? Different materials are going to offer different performance for different chemicals. That's why it's good to look at the chemical resistant chart and try to identify, and the SBS, and try to understand what rubber material compound is best. Some rubbers might be good, some might be great, some might be okay. It's about permeation. So how long is that glove going to be exposed to that chemical? If you're just opening a container and decontaminating some chemical into another vat or something, and it's only 30 seconds or a minute, you might be able to get away with a couple different materials, nitrile, natural rubber, neoprene. But if it's a more aggressive chemical and you're handling that, say, 3-4 hours a day, every day, you might need something more aggressive to get that permeation or reduce the permeation. So it's all about breakthrough time, really understanding what the chemical is, and then, okay, do we have the right material? And again, the SDS is going to indicate what material you should be looking at, and then I would reference that back to the chemical selection guide. Once you identify, okay, it's PVC, then you go to the chemical product offering and you find the PVC gloves that would suit your application from an attribute perspective. And so step one, what is the chemical? Step two, where's the SDS? Step three, what does it say on the chemical chart? Step four, what are my options? And again, how long am I exposing that product to the chemical? When the chemical is exposed and you're getting breakthrough, the chemical glove will start to bubble, almost like burnt skin, like blistering in a way. So the chemical glove will start to blister. That's an indication you're getting breakthrough or permeation.
Gotcha. Okay, awesome. Thank you. And are all your gloves washable and reusable? If so, how many times should you wash before you replace?
That's a good question on like the number of cycles. We don't have a laundering program. However, we have laundering guidelines. Again, be happy to share that with you. Just kind of cover over some, what are the temperature ratings by material, whether that's nylon, cotton, Kevlar, or pararamid, leather. So leather dry cleans really well, but leather doesn't wash very well in your standard industrial washer. So if you're looking at a string knit glove, yeah, you could wash that several times before it starts to break down. So don't have any specific information on wash cycles by product, but I can tell you that yes, most gloves launder quite well. Lots of people are laundering gloves today. It's becoming more of a common practice to get more of a use and service life and longevity. And then again, we have some guidelines of things to kind of stay away from, bleach and that sort of thing. But as a general rule of thumb, gloves launder well. It's a common practice, and there's a lot of companies out there that are now offering that as a service. And so, yeah, it's definitely something that can be done.
That's awesome. Allison says that was super helpful on the chemical gloves question. Very much appreciated.
You're welcome.
And Tom asks, while you aren't speaking about vibration today, is there a testing standard for vibration as well?
There is. I'm not going to throw out the reference because it escapes me off the top of my head, but yeah, great question there. Vibration, really that, pneumatic tool handling something that's that continuous vibration, how long and what's the level of vibration. And then not only that, there's very specific materials that you want to use for anti-vibration, true anti-vibration. So it really just depends. Is it a nuisance vibration? Maybe we're doing a little grinding, prolonged grinding, or is it a true anti-vibration hazard? Because if it's, more than nuisance level, like somebody's exposed to it for 8 hours a day or a work shift, there's very specific materials you want to use. But we have our vibration hazard catalog. You'll go in there, you'll see some of the different vibration options using different materials like EVA foam and really dampening that vibration hazard. So that's a great question. We do have some more technical information. So if I get that question directly, I will absolutely follow up with a bit more specific, detailed information. But yeah, there's definitely very specific protection and guidelines for anti-vibration and really to reduce that HAVS syndrome, white finger syndrome. So yeah, white hand syndrome. So yeah, great question. Lots of information. We'll be happy to provide that back to you in more specific.
Beautiful. Thank you. Maybe time for just one or two more here. Is there a respected standard to inform for usage within the food handling setting?
A lot of the products are under the CFIA and FDA compliance. We also have a clean room process in our facility, and so a lot of our gloves are clean room process. But yeah, there's guidelines for CFIA and FDA. So when we launch a new product that we're marketing or that's geared toward the food industry, we always go out. In most cases, we go out for CFIA and FDA approval. And so, yeah, there are guidelines there. As a manufacturer, we adhere to those guidelines if we want to claim and publish the CFIA, and we do. We know when we're working with the big food companies that that's important. And so, making sure that stuff's not flaking off of the product and falling into the gloves. Yeah, there's definitely standards, and we have a lot of food safe gloves. And no surprise, you'll find our food safe hazard specific catalog in the resources. So you can go straight to food solutions, and I could also provide you a list of our CFIA FDA approved products if that was helpful for you.
Awesome. All right. Well, unfortunately, we have reached the top of the hour, so time to wrap things up for today. Once again, this presentation will be shared early next week along with all resources with all the registrants in case you missed anything. Thank you to everyone who attended and for asking questions. A special thanks to Shane for being here with us today, as well as Superior Glove for sponsoring this webinar. Really appreciate you taking the time out of your day to present this for us. Have a great afternoon, everybody, and thank you once again.
Great weekend, everyone.